Hello again, MSM3 students. We're shifting gears a little bit today. We are going to be looking at angle relationships when there are intersecting lines. So the first part of this is very vocabulary heavy, and then we'll start looking at the different relationships in the second part of this. So first thing, let's review a couple pieces of vocabulary. Two angles are complementary if the sum of their measures is 90 degrees. For example, the complement of 30 degrees would be 60 degrees because 30 plus 60 equals 90. So what would the complement of 100 degrees be? Well, we're trying to make 90, so the only thing that you could add to 100 to make 90 would be negative 10, but you can't have a negative angle. That doesn't make any sense. It's kind of silly. So actually, this is not possible. There is no angle that I can add to 100 degrees to get 90. So there's no complement to a 100-degree angle. Second piece of vocabulary that you should already know or be familiar with. Two angles are supplementary if the sum of their measures is 180 degrees. So the supplement of 50 degrees would be 130 degrees because 50 plus 130 equals 180. So remember that a 180-degree angle looks like a straight line. So this next question says, what is the supplement of angle 1? Well, here's angle 1 right here. And you can see one of the rays of angle 1 is on this straight line right here. So what other angle would go with angle 1 to complete this straight line? So it starts here. Here's the ray. Well, look, this ray is shared with angle 2. And it's along that straight line. So angle 1 and angle 2 would be supplementary. But I know some of you are thinking, wait a minute, there is another straight line, and it's right here. So angle 1 is also along this straight line. And if I continue that line, there's that straight line that an angle 3 is on it. They both share this ray, and then this straight line makes up the other ray of both angle 1 and angle 3. So you can have two possible supplements to angle 1 in this figure. What's the supplement of angle 8? Well, as we just saw over here, the supplements are the angles that are right next to the angle you're talking about. So if we go here, angle 8, what is right next to it? Well, angle 6, and that makes sense. There's the straight line that these two angles together make. So angle 6, or here's the other straight line. Angle 7 is right next to angle 8, and it is on that other straight line. You don't need to give both answers. You certainly can, but there are two possible answers for this. A transversal is a line that intersects two or more lines in a plane at separate points. In the figure above, what is the transversal? So you can see we've got them labeled R, S, and T, and you can see right here, angle R goes through both angle S and angle T. Or, sorry, line. I just said angle. I meant line. I guess they are angles as well. But line R is the transversal. It goes through both S and T. Vertical angles are angles that have the same vertex and whose sides are opposite rays. So let's start with angle 1. Same vertex, but opposite rays. Let me erase this so it's a little clearer again. Okay. So here's angle 1. There you can see the vertex, or the rays that make it up. Here's the vertex. Same vertex, but opposite rays. So what is vertical to angle 1? That would be angle 4. Basically, they're across from each other or opposite one another. So let's look at angle 2. Here's the vertex of angle 2. Here are the rays of angle 2. What has the same vertex but opposite rays? That would be angle 3. So let's go down here. Angle 5. What would be vertical to angle 5? That would be angle 8. And then the final pair, cross from each other, angle 6 and angle 7. Corresponding angles are angles that when two lines are cut by a transversal, they are in the same position with respect to the two lines and the transversal. So angle 1 is above the transversal and to the left of the line that's cut by the transversal. So shift to the other section. Angle 5 would be corresponding to angle 1 because it's above the transversal and to the left of the line that the transversal cuts. So angle 1 and angle 5. What would be another pair? Well, let's look at angle 2. This one's to the right of the transversal, to the right of the line cut by the transversal and above the transversal. So angle 2 and angle 6. And then if we go angle 3, it's below the transversal and to the left, below the transversal and to the left. So angle 3 and angle 7. And then that finally leaves angles 4 and 8. Alternate interior angles. Notice that word interior, inside. Alternate interior angles are angles that when two lines are cut by a transversal, they are between the two lines and on opposite sides of the transversal. So here are the two lines cut by the transversal. So we're going to go inside. So angle 2, and then opposite the transversal, that would be angle 7. Now I know some of you might be thinking, well, wait a minute, number 4 is also opposite the transversal, but we already know that those are supplementary, so that wouldn't work. So it's going to be angle 2 and angle 7. The other pair, angle 4 is below the transversal and inside. Angle 5 is above the transversal and inside. So 4 and 5. And then finally, our last piece of vocabulary here, alternate exterior angles, exterior meaning outside. They are angles that when two lines are cut by a transversal, they are outside the two lines and on opposite sides of the transversal. Here's the two lines that the transversal cuts. So we want outside. So 1 and opposite sides of the transversal. So 1 and 8. And then 3, what is the other one that goes with 3, the other alternate exterior? That would be angle 6. So 3 and 6. So that's the basic vocabulary. I'm going to end this video here and do a second video for part 2 where you're going to learn the relationships between these different angles. So I will be right back.